Hello students, I am Subhashish. Previously, we have learned about compound interest. Let us recall the compound interest. Compound interest is the interest calculated on the principal and the interest accumulated over the previous period. It is different from simple interest, where interest is not added to the principal while calculating the interest during the next period. Today, we are going to learn the applications of the compound interest formula and the difference between compound interest and simple interest. Learning outcomes. After the completion of this lesson, you will be able to know to be able to find interest by using the compound interest formula. To find the difference between compound interest and simple interest for 2 years and 3 years. Keywords from this lesson are interest, increase, decrease, depreciation, simple interest, compound interest, principal, rate of interest, time period. Applications of compound interest formula. The compound interest formula is used in the following situations. To find the increase, P into 1 plus R by 100 whole power n, or decrease, P into 1 minus R by 100 whole power n in population. To find the growth of cells when the rate of growth is given. To find the depreciation in the values of machines, vehicles, utility appliances, etc. Let us see one example. The value of a motorcycle 2 years ago was 70,000. It depreciates at the rate of 4% per annum. Find its present value. Solution. We know depreciated value is equal to P into 1 minus R by 100 whole power n. Now substitute the values in the formula. We get 70,000 into 1 minus 4 by 100 whole power 2. By taking LCM and solving for power 2, we get 70,000 into 96 by 100 into 96 by 100. Then by simplifying we get 64,512. Therefore, present value is 64,512 rupees. Let us see one more example. The bacteria in a culture grows by 5% in the first hour, decreases by 8% in the second hour, and again increases by 10% in the third hour. Find the count of the bacteria at the end of 3 hours if its initial count was 10,000. Solution: bacteria at the end of 3 hours, A is equal to P into 1 plus A by 100 into 1 minus B by 100 into 1 plus C by 100. Now substitute the values in the formula. We get 10,000 into 1 plus 5 by 100 into 1 minus 8 by 100 into 1 plus 10 by 100. By taking LCM and by solving, we get 10,000 into 105 by 100 into 92 by 100 into 110 by 100. Then by simplifying, we get 105 into 92 into 1.1. Then by multiplying all the values, we get A is equal to 10,626. The count of the bacteria at the end of 3 hours is 10,626. Let us see one more example. Find the compound interest on rupees 3,200 at 2.5% per annum for 2 years, compounded annually. Solution: given principal P is equal to rupees 3,200. Rate of interest R is equal to 2.5% per annum. N is equal to 2 years compounded annually. We know amount A is equal to P into 1 plus R by 100 whole power n. Now substitute the values in the formula. We get 3200 into 1 plus 2.5 by 100 whole power 2. Then by solving, we get 3200 into 1.025 whole square. Then after multiplying, we get 3362. Compound interest CI is equal to amount minus principal, that is 3362 minus 3200, which is equal to 162. Difference between compound interest and simple interest. There is no difference in compound interest and simple interest for the first year or the first conversion period. For 2 years, the difference between compound interest and simple interest is Ci minus Si is equal to P into R by 100 whole square. For 3 years, the difference between Ci and Si is Ci minus Si is equal to P into R by 100 whole square into 3 plus R by 100. Let us see the examples. Find the difference in compound interest and simple interest for P is equal to rupees 5000, R is equal to 4% per annum and N is equal to 2 years. Solution. We know for 2 years compound interest minus simple interest is equal to P into R by 100 whole square. Now substitute the values in the formula. We get 5000 into 4 by 100 into 4 by 100. Then by simplifying we get 8 rupees. Let us see one more example. Find the difference between the compound interest and simple interest for 2 years for a principal of rupees 5000 at the rate of interest 8% per annum. Solution. The difference between simple interest and compound interest is given by the formula compound interest minus simple interest is equal to P into R by 100 whole square. Given principal P is equal to 5000, R is equal to 8% per annum. Now substitute the values in the formula, that is Ci minus Si is equal to 5000 into 8 by 100 whole square. Then we get 5000 into 8 by 100 into 8 by 100. Then after simplification and by multiplying we get 32 rupees. Let us see one more example. Find the difference between compound interest and simple interest on rupees 5000 for 1 year at 2% per annum if the interest is compounded half yearly. Solution. Given principal P is equal to rupees 5000, time period N is equal to 1 year, rate of interest R is equal to 2% per annum, for half yearly R is equal to 1%. The difference between compound interest and simple interest is given by the formula Ci minus Si is equal to P into R by 100 whole power 2n. By substituting the values in the formula, we get Ci minus Si is equal to 5000 into 1 by 100 whole power 2 into n, which is equal to 5000 into 1 by 100 into 1 by 100. Then by simplifying we get rupees 0.5. Points to remember. compound interest is equal to amount minus principal. Simple interest and the compound interest remain the same for the first year or the first conversion period. For 2 years, the difference between compound interest and simple interest is compound interest minus simple interest is equal to P into R by 100 whole square. For 3 years, the difference between compound interest and simple interest is compound interest minus simple interest is equal to P into R by 100 whole power 2 into 3 plus R by 100. Thanks for watching.